Hello friends, in this video we are going to discuss about a GATE numerical that has came in the previous question. According to the given numerical, it is written that determine the values of N0, P0 for silicon at T equals to 300 K if the Fermi energy is 0.22 electron volt above the valence band and given Nv equals to 1.4 into 10 to the power 19 per centimeter cube and Nc value is given by 2.8 into 10 to the power 19 per centimeter cube. That means in the energy band diagram, if this is the Ec and if it is the Ev, and it is said that the Fermi level is 0.22 electron volt above the valence band. So we can say if it is the Fermi level of the semiconductor given in the numerical and this gap is given by 0.22 electron volt. So Nc value and Nv value are given, so we can say that P0 is equals to Nv exponential minus Ef minus Ev by Kt. So P0 value can be written as Nv value is as 1.04 into 10 to the power 19 into exponential minus Ef minus Ev is given by 0.22 electron volt and Kt value will be 0.026, and from this calculation we can find that P0 will be 2.19 into 10 to the power 15 per centimeter cube. So this will be the value of the P0 in the semiconductor. Now we can find the Eg. Eg is given by Ec minus Ev, and this Eg is also given by 1.12 electron volt and it is Ec minus Ev. So from this equation we can find that Ec minus Ef will be equals to 1.12 minus 0.22. That means we can say 0.90 electron volt. Now this value of Eg is nothing but the band gap of the semiconductor, and semiconductor is given by the silicon. Now N0 is equals to Nc exponential minus Ec minus Ef by Kt, and Ec minus Ef is 0.9 and Nc value is also provided, that is 2.8 into 10 to the power 18 into exponential minus 0.9 divided by 0.026, and this is will be 2.59 into 10 to the power 3 per centimeter cube. So this will be the value of the electron at the sample, and P0 is the value of the holes in the sample. So this is all about the numerical given. Thank you.